OSI model. Now, I know a lot of people, oh, OSI model, we don't want to talk about that. But really, it helps frame the concept of what's going on within this network, okay? And it's a language. Like I said, it's a common language to describe how to describe a network. And it's a really good troubleshooting tool also. If you're having problems, you kind of know where to look in the stack, as we call it, for where the problem could be. So when we think about this, okay, let's look at it from this perspective. All right, so we got two computers, right? They want to talk to each other. And I said we have a sending computer and we have a receiving computer, two computers. Well, to do that, this sending computer, it walks through about 7 layers. This is in this OSI model. There are 7 different layers, things that has to happen as it goes down to get that information, to get it formatted into the right format, so that now we can put it out across the internet and get it back up, those same 7, to that receiver computer. Now, when we think about these layers, they all have a different function. And I'll also say, for teaching purposes, this looks very clean and neat. But in reality, some of the protocols that lie in these layers, they overlap. So there are some overlapping in these layers. So we look at the first set of layers up here at the top, and these layers are usually found in your operating system. When we're talking about layer 7, layer 6, layer 5, and layer 4. Now these are like we talk about the higher level layers compared to the bottom 3, our lower level. So what happens here in layer 7, this is actually what gets your information ready, okay? This is what really, these are the protocols that talk to the user applications on your computer. So let's say if you had Microsoft Word, right? Or yeah, let's use Word, and you want to send a email with a Word attachment, right? With a document attached to it. Well, what prepares that Microsoft email and Word are the protocols that's associated with layer 7. For instance, if you want to send this across the internet, well, HTTP, Hypertext Transfer Protocol, and hopefully everybody's using the secure version of that protocol. That is what actually now prepares your information, or your computer, to be able to talk to Internet Explorer or Google, or whatever the internet service that you are using. That's what does that. So this is what this layer 7 does. It actually lies right up underneath all of you within your operating system. It just kind of sits right there underneath your user applications and other applications, and it prepares these things to go down. Then it takes it to layer 6, what we call the presentation layer. Now, presentation layer, what this does, it prepares your information so that when it gets to the other end, this can recognize it. If I just had a bunch of text or data, and I sent it, this computer over here would not know how to recognize it. But if I format this in a format and call it a .docx, like a Word document, then it knows what to do with it. So you'll see protocols here like MPEG and JPEG. This is how we're able to send pictures and music files and things like that across the internet, so that one computer can send it. So or if I want to encrypt, let's say I got my Word document and I want to encrypt that. Well, that's where I use things like secure shell or secure socket layer to be able to do that. So that's at layer 6. Layer 5, that's what we call a session layer. Now, for these two computers to talk, there's handshaking that has to go on, and they have to establish a session, meaning that, okay, you tell me how you're going to be configured, I'll tell you how I'm going to be configured, and then we configure it ourselves so we can talk to each other, so that now we set up a session. Once that information is finished being passed, now we want to take that session down. It's kind of like a phone call, right? For me, if I'm in the United States and I want to call someone else in the United States, there are protocols of how I'm going to do that. I'm going to dial 1, if it's, and then the area code, and then the number, right? And hopefully the other person on the other end picks up. But before they pick up, the phone system do some handshakes. So that these two telephone numbers that they shake, okay, I know the protocol, and yes, boom, I can answer your call. So, and then when we finish talking, what do? We hang up. We disconnect that session. So up until this point, we're working with data. This is just a bunch of data, a bunch of ones and zeros. Now we get to layer 4. Layer 4 is the transport layer. Now what this means is it is getting your information ready to be transported. It's not transporting it yet. Your lower 3 layers will do that. But this layer 4 is now getting it ready to be transported. I liken this to, let's look at these top layers as a coal mine, right? Out here, they're just digging coal, and they got big piles of coal sitting out there. And that coal is in West Virginia, but it needs to get to Atlanta. Well, to get there, how do we prepare it to be moved? Well, what they do, they'll put it in box cars, yeah, in segments. And so much of it will go in each box car. You see these long trains, especially if you live anywhere on the East Coast or somewhere you get with, sometimes hundreds of box cars of coal and as it goes down the track. That's what layer 4 kind of does. It takes all of this data that's been fed to it from the upper layers, layer 7, layer 6, layer 5, and the your applications. Bunch of data. Now, we need to start breaking this up so we can be able to get it transported. So it breaks it up into segments, okay? And what a segment is, it is just a grouping of your data. Sometimes you hear called MTUs, but it's about 1,500 bits, and it takes those 1,500 bits of data, and so now it can package that. Okay, so now it can put it in a package, and I can also do other things to it. I can put a header on it. When we talk about headers, like I say, this is basically like mailing a letter. If you think about putting an address label on a package, that's all a header is. So now I've got my little bit of data in a box with an address on it, and it knows how now it's ready to be packed. It's ready to be sent. So that's what these upper layers do. The layer 4, 5, 6, and 7. Now, think about this box. I've got it packed, or the train, right? I've got all this coal in these boxes, in these box cars, but the engineer don't know where to go. Okay. Now with the rail system, a little bit easier because you're on a track, but still they have to be able to route that train to where it needs to go, and that's what layer 3 does. Layer 3 does your routing. So now this train, it gets to a depot where now you got multiple tracks, and the engineers and they can make it switch tracks to go where it needs to go. That's what they are doing. They are physically or manually routing that train to get from West Virginia to Atlanta. Okay, and if they misroute it, that train may end up in St. Louis. So that's what layer 3 does with our information. It establishes routing paths, and it knows all these different routers in the network. And now what it also does, it puts another header on that packet called an IP. This is where the internet protocol comes in. Sometimes you hear these 2 layers, 4 and 3, kind of bundled together, call it TCP IP. Because at this layer 4, that's where we have our transmission control protocol, TCP, transmission control protocol, and UDP, user datagram protocol. But yeah, so sometimes we talk about these 2 together because at layer 3, this is where we have our internet protocol. Now, that internet protocol is what, once your packet gets out there into the internet, okay, onto the digital highway, that way the header on it, it knows how to route it as it goes, as it's going across the internet, and it could take multiple paths, who knows. But these 2 protocols work together. Here's how. So I got this data. I want to send it from this computer to my receiving computer, and I want to use I want to be sure that it gets there. This is an email, right? I want to be sure that email. So when this person up here opens up this email, I want everything to be in that email. So what type of protocol would I use to do that? I would use TCP, Transmission Control Protocol. What TCP does, remember we talked about it puts in little boxes or box cars? Well, it numbers and counts every one of those box cars, right? And every one has a number on it. Every package has a number. And when it sets up this session between the 2, it tells the other one, hey, at layer 4, I am sending you 100 packets. And they're all sequentially numbered. Now, at the end of this session, the receiving computer's layer 4 may say, I didn't get 100 packets. I only got 97 packets. As a matter of fact, I can tell you what 3 packets I didn't get. I didn't get 17, 21, and 96. This computer over here at layer 4 says, you didn't get it? Well, guess what I'm going to do? I am going to resend those 3 packets. And it resends it, and now it has it. And now it can go up and do everything it needs to do and put that email back together. So now when the receiver opens up the email, then you got the complete full email. That's how TCP operates as a protocol, transmission control protocol. It's called a connection-oriented protocol. So that everything that's being sent, there's handshakes, and it's guaranteed. Kind of like registered mail. You know, that guarantees that somebody has to sign it, and for it, you signed it when you sent it, and it's assured delivery. The other protocol here is UDP. That's a connectionless protocol, meaning that, you know, we're not doing all this packet counting, guys, okay? So when UDP is going to send something from layer 4 of the sender machine to layer 4 of the receiving machine, it's kind of like junk mail, meaning that we're just going to keep sending it, sending it, sending it. You know how you get junk mail? You know, you get mail from the people who lived in the house before you because it don't care. You're just going to, and UDP operates that same way. I mean, it's just going to keep sending those packets. And you may say, well, why will we ever want to do that? Here's why. Because if you're watching this video right now, you're probably streaming it over YouTube or some streaming platform where you're watching it live or real time. If you're not watching it real time, you're using UDP to do that. Here's why UDP is used in this environment for things that streams, like audio, if you're streaming music, if you're streaming video, whatever it may be. Because if you're trying to do this, if you're trying to use TCP and do packet counting and assured delivery, your video would look like that. It will be broken up into pieces because it's trying to do this handshake and everything else, whereas you really can't do that with video. So that's why UDP is used for certain applications for streaming. Because if some of the information drops out and get lost, it really doesn't matter, you know, because unless it's a lot, the end user is never going to see the difference, okay? So that's why these 2 protocols are used here at layer 4. Like I say, layer 3, that's where we got IP. That's where it puts that header on there, and it says, okay, you're going to go down the internet, buddy. Here's a header. That way you know how to, so when it gets to the next router, it looks at the header. Okay, you're trying to get to St. Louis. Here you go. Boom, let me put you on this route. That's all routing is. Now, that packet gets to your house. Well, let's say this computer right here is sending it. Well, before it can send it, it has to go through layer 2. Now, with layer 2, this is your switch. This is your data link layer. This is where your devices, like your computers and all the network devices you have in your home, are connected to this layer 2 device. That's how you actually get connected, and from there it connects you to the router. So that's how you build a local area network within your home. Now, once layer 2 gets it, then they can send it out layer 1. Layer 1, what that is, like I said, that's your physical layer. That's where you got your cable, your fiber optics, your Ethernet cable. It could be wireless. You know, it could be 5G, 3G, or 4G, 5G, cellular. This is how your ones and zeros actually get out there. So here again, that's how it goes from a sender, goes down that stack, goes across, comes back up the stack, back to the receiving computer. Now I will tell you this from a cybersecurity perspective, all right? And you know me, I love the cyber side of the house. That's where I work in right now. This is where vulnerabilities lie in this transmission path. Is here in all the protocols at each layer. Now, if I'm a bad guy and I know how protocols work, now I can do denial of service attacks. I can do spoofing. I can do man in the middle, because I am able to intercept or interleave myself, because I know how where the vulnerabilities are in these various protocols. Okay, so now, like I said, but for the purpose of this class, we really focus on these last 3 layers. Okay, layer 3, the network layer; layer 2, the data link layer; and layer 1, the physical layer. So looking at these 3 layers, okay. Now, I'm going to walk you through this scenario, and I've kind of been using it all along, but we're going to get into a little bit deeper on comparing how the U.S. postal system and our current networking architecture, how similar they really are. All right, and this is totally 100% fictitious. Okay, none of the characters are real. All right, and no animals were harmed in the making of this scenario. I know you got to cover all bases. All bases. No hemp products were used. I don't know. What are the things out there? None of those things were done in the making of this. All right. So how does this scenario start out? Here's how it starts out. Okay. This is my house. This is my house right here. All right. I live in Texas. Well, actually, I do live in Dallas, Texas. But don't come to 111 Nate Drive. I don't even know if that exists. But so I live in Dallas, Texas, and my grandmother, she lives in Texas also on 225 Penny Street. And I love my grandmother, and my grandmother loved receiving letters from me because she's old school and she's not into the texting things yet. So she just like those old school letters, you know, and you get the stamp and you smell it and see if they put any perfume on it or not. That's my grandmother. All right, so so I like writing letters to my grandmother. Now, if you look at a letter, right, this is the U.S. postal system. They have a protocol that they use for us to send letters. We don't think about it because we do it all the time. Their protocol is this. You have to have your destination address here. You have to have your source address here, right? And you got to have that stamp right there with the right amount on there. Those anywhere stamps or never go bad stamps. But that's the protocol to mail a letter. Now, within networking, we have a similar protocol that we use, okay? And that protocol of how we do addressing. And it's our IP addressing schema. Right now, there's two. We have IPv, IP version 4. We also, which is still very widely used, but we are slowly transitioning to IP version 6. You may have IPv4 or IPv6. For the purpose of this, we're just going to talk about IPv4, okay? So when we think about IP version 4, what that uses is a 32-bit number, from 1 to 32, or actually from 0 to 31 is really what it uses, from 0 to 31. But those 32 bits, that's how many fields, or how many you have, of ones and zeros, because it's binary. We're talking binary, that you can set up an IP address with. Now, what we do, we take those 32 bits and we break them up into 4 groups. 4 groups, and each of the group would have 8 bits. So we got 4 groups with 8 bits, okay? And each of these groups of 8 we call octets. Octal, 8 octets. So we got 4 groups of 8. And what that is for, it has nothing to do with the computer. The computer, the network, the routers, it doesn't care. This is for us humans. Why? Because if we had to memorize a 32-bit stream of numbers for addressing, that would get pretty arduous. So then what we do, we take these octets, and they're all still binary. Like I said, all we did was take that one thing and broke it up, the 32-bit, broke it up into 4 octets, and then we do a conversion. Okay, we do a binary to decimal conversion, what we call dotted decimal. So what we do is convert each of the octets separately. So I'm not going to get into binary conversion. That's another part of the class, or another class later on. But just kind of trust me on this. If I convert this right here, 1 1 0 0 0 0 0 0, it becomes 192. Likewise, this octet converted becomes 168. This octet is 1. This octet converts to 15. So you've heard that the way people talk about IP addresses. 192.168.1.15, right? That's a much easier way for us humans to communicate to each other, as opposed to 11000001010101100. Enough of that. So you see it. If you ask me my IP address and I try to give you that string, you go crazy. But if I gave you 192.168.1.15, gotcha, right? So that's the addressing schema that we use, or the protocol that's similar in a mailing protocol. All right, so now I got my letter addressed, and what do? I put it in my mailbox. The little guy in his truck comes and picks it up out of my mailbox, and he transports that to a local post office. right there in our area. Everyone has a local post office somewhere not too far from your home, right? So that right there, think about that. Now just transporting this from point A to point B is similar to the physical layer. That's layer one. Okay, layer one in the mail system is the highways and the roadways. Layer one in our network environment, that is your copper cable, your fiber optics, your Wi-Fi, whatever it is. But all that is doing is getting information, your data. It's not even information, you're getting data from point A to point B. So now I've got it here, right? Now, what does this local post office do? This local post office does something pretty special, okay? Here's what they do. They look at the zip code of the destination address and the source address. Now, that zip code, if you notice, is the same, 75042. Well, that local post office now knows that, hey, that's a local delivery. All I got to do now, I can take this letter and drop it onto another truck and take it right over to 225 Patty Avenue because I know Penny Avenue because I know exactly where that is. That is a local area delivery or a local area network. That's what layer 2 does in our home networks. Layer 2, that switch. You may say, I don't have a switch. I'll show you. You do have a switch later on. Connects up all of your devices. And if your computer wanted to send something to the printer, that switch knows that, hey, I recognize the IP address. It does some binary addition and says that IP address is local. It's actually connected to me. So it will take that information off of your computer through the switch and wirelessly send it to that, or if you got it connected up with Ethernet, to your printer. You don't have to be connected to anything else. This switch doesn't have to be connected to the internet or anything else, and you can print. That, my friends, my students, my constituents, that is a local area network. Just like the mail system here, where they did a local delivery. All right? Good with that? But what happens next? Well, my dear grandmother, one day, she up and moved to California. She looked at me and said, grandson, I'm going back to Cali. Cali, yes. So she went to California, just up and moved to 345 Sunny Beaches Cove, Los Angeles, California, 90210. 90210. All right, that's the new zip code. New address, new zip code. Well, me still wanting to be able to mail my grandmother letters, I do the same thing I always do. I send it to my local post office. My local post office then does what they always do. What do? They look at the zip codes and go, wait a minute. 9021 is 75023. I recognize that. But however, 90210, I don't have a clue where that is. I have to send it now to some type of a routing station. Okay? Now, where this post office goes, it says, hey, I know that if I send that to St. Louis, because that is our default location for sending mail, kind of like a default gateway or default router. Now, St. Louis will say, hey, I got this letter. I know exactly where 90210 is. And you know what? And I know how to get it there. So it takes this letter and it routes it to a local post office in San Bernardino. And it goes, I know where 90, and it looks at it and go, oh, I got it. Hey, 345 Sunny Beaches Cove, I know exactly where that is. And it puts it on layer 2, I'm on layer 1, and sends it to my grandmother's house. So in effect, this St. Louis post office is operating as a layer 3 device. A layer 3. Now what layer 3 devices does, this router, in effect, what it does, it connects disparate local area networks. Meaning, I have a local area network here where I live. There's a local area network where my grandmother lives, but the two aren't able to send traffic or send mail back and forth to each other. That is what this router in the middle does. This router now is able to connect from this local area network through this and route it to the other local area network. That is what a layer 3 device does, okay, in your network. And it does this routing based on the IP address. In the case of the U.S. mail system, it again uses that zip code to know how to route mail throughout the postal service. So we've got layer 2, our local area networks, and we've got a layer 3 device, which is part of we'll call it a wide area network, and we're going to talk about that a little bit more in a minute. Now, something else happens in the process of doing this. It's something, and it's important to know in our networking environment. It's called encapsulation and decapsulation. Here's what I mean. All right, so I take the letter that I'm going to write. Right, I write it, I handwrite it because she likes reading handwritten letters, and I put that letter inside of an envelope. And in effect, what I've done, I have encapsulated this piece of paper inside of an envelope. It's the first stage of encapsulation. Now, when I take this, and when the postman comes and they grab this, they take my letter, put it into a mail bag, basically with a bunch of other letters. So now they've encapsulated my letter in a bag with other letters. To get to St. Louis, they take that bag and they put it on a pallet with other bags. So now what do I have? I have a letter encapsulated inside of an envelope with a header on it. That envelope is encapsulated inside of a bag with another label or a header on it. And that bag is encapsulated in a pallet with a label on it. And then when it goes, that is encapsulation. Then when it goes across country, well, kind of the opposite happens. They take it out. When it gets here, they pull it off the pallet, pull the bags out, take the bags, take the letters out, sends the letter, and then my grandmother gets the letter. She opens the envelope, takes the letter out. So what do we have? We encapsulate it, and then we start decapsulation. Same thing happens on our network when we're sending information, when we're sending traffic data back and forth. Let's give you an example. Okay, here's Keyboard Cat. All right, Keyboard Cat. I can just never get enough of Keyboard Cat. So I want to send videos of Keyboard Cat to my all my friends, all of them, all 2 of them. So so at these upper layers, layer 4 or 5. Layer 4, 5, 6, 7, and 8. 5, 6, and 7. These upper layers. We put an application header. So here's my video. So I encapsulate that video with an application header. When I send it down to layer 4, what do? I put a TCP header on the front of that. So I got 2, it's encapsulated twice. Gets to layer 3, I put an IP header on that. Because that way it knows how to start doing the routing. And then then at the next layer, layer 2, this is where I will put an Ethernet header. So my video back here, you see has been encapsulated inside of multiple things before it goes out as ones and zeros across the internet. What happens at the other end? Just the opposite. Well, first, at the other end, they receive the ones and zeros. Then what do? And when it goes to layer 2, they strip that header off. That Ethernet header gets stripped off and goes up to layer 3. The IP header gets stripped off, and it's sent to layer 4. And you kind of see how it's going, right? TCP header gets stripped off, goes up through the next 5, 6, and 7, and then everyone is able to enjoy, both of my friends, that Keyboard Cat video. So we've talked about a lot of things here, right? Now let's take a look though with your home network. If you can remember that analogy we just finished up, especially those last 3 layers, the physical layer, the data link layer, and the network layer. Now let's apply this to your home network. All right, so we have 2 things that's working at the same time. You have local area network and you have wide area networks. Yeah, right there going on your home. Here's what I mean. So if you look at here's your home devices, your computers, laptops, TVs, everything you want to get connected to the internet. To do that, you have a device that we call a router. Actually, that is actually a layer 2 and a layer 3 device. Here's what I mean. If you look at the back of most of your routers, you see it has 4 ports. LAN. Those are your LAN, your local area network ports. This is what connects up to your devices. And these could be connected up via cable, or it could be connected up via wireless. But either way, that's connecting the local area network side, which is your layer 2 switching side. Now on the other side of this, we have a WAN, wide area network port. That's going to go the other direction. So, but let's talk about this first. So here's all your devices. So how did this, even if we hook the cables up, how does this device, your router, know what these are? You know, is it just magic? I don't know. No, it's not. Well, what happens, every network device comes from the manufacturer with a MAC address, Media Access Control Address. And that MAC address is hard-coded into the network interface card of every device. And every manufacturer who makes a network device, they have their own unique set of MAC address numbers that they use, okay? And these MAC addresses, they are hexadecimal numbers. They're not binary, they're not octal, they're not decimal, they are, hexadecimal. Hexa meaning that there are 16. So you got 0 through 15. And that means you have to use alphabets. And that's where sometimes you see these alphabets, because we only got 0 through 9, 10 digits. So then we start with A through F in hexadecimal. So, but every device, it has a hexadecimal number. This is what, 14.9D9981.6F.A3. That is an example of what a MAC address looks like. Well, why is that MAC address important? Well, because at layer 2, we're not talking IP addresses yet. This is where now this part of the switch is able to recognize the MAC address on every device that connects it up to it. And inside of there, it has a little database, right? So that it records the MAC address of every device. So like I say, if you buy a new phone, you bring it home and you want to connect it up to your Wi-Fi. Well, there's a MAC address on your phone. If you go down through your menu settings, you'll find that MAC address. Well, once you're given permissions, you got the right encryption and the password and everything to log onto this router, then the switch portion of this router, the local area network side, it will remember the MAC address of your phone, unless you want to go and clear it out, which you can. So every device now is connected to the switch. Then what happens? Well, now this router says, okay, I know who you are. I recognize your MAC address, but we're going to be able to communicate until you get an IP address. So this then provides an IP address to every device in your home. Now, this is the layer 2 side, the local area network side. Now, on this side of your router, it's using Class C IP addresses, and these are private IP addresses, meaning they're not out. You don't see them out here in the internet. You should never see a 192.168 IP address crossing around on the internet. These are just inside of your home. This side right here, this is all inside of your house. So this right here starts giving IP addresses to every device that has a MAC address. And typically, out of the box, you have the ability to let it give 254 IP addresses. You can assign 254 devices to that LAN before you have to start doing something special to make it work. Basically 192.168.1.1 all the way to 192.168.1.254. Okay, so now we got all of our devices connected up. We're happy, right? Kinda. I can talk to my own computers in my own house, but I want to be able to get out to the internet. That's where it all happens at, right? On the internet. How do we do that? Well, that's the second part of this. This is the wide area network side of your router, okay? That one port that connects up, to your internet service provider. And it may be a modem, or it could be a fiber modem, or it could be cable, depending. But that just depends on who your internet service provider. Now, what they do, your ISP. Now, Connecting to your ISP still have not got you to the internet, okay? Don't confuse that. You know, if your Verizon is your internet service provider, they are the ones who give you a path to the internet. They are not the internet yet. All they're doing is now you're just giving you a path. So what they will do is that they are going to assign you your home, one IP address. Even though you may have, 50 devices in your home, this machine, this device, using what we call DHCP, Dynamic Host Configuration Protocol, it is able to assign a lot of IP addresses over here, but then when it goes in and out, it only goes out of one IP address to the internet. No different than the US mail system. Here's what I mean. Your house has how many addresses? One. You could have 15 people living there. All 15 can write letters to 25 different, like Christmas cards. You could have 10 people in your house sending Christmas cards to all of their friends, right? That would be this part over here. Whole bunch of, Christmas cards, all addressed to go different places. But at the end of the day, you're gonna bundle those cards up, and you're gonna have one address as the sender address, your one house address. That is what your internet service provider does. It gives you one address. All that traffic is going to go. And that is typically a Class B, sometimes it's a Class A IP address, like in this instance, 47.189.55.169. That is your one address, and I kind of made this up, fabricated that, but yeah, that would go to your house. So as you see, the LAN side and the WAN, the wide area network side. Now, if you haven't played around with your home router, carefully do this. You can actually log into your home router. Let's say, and this is just a Linksys, but most of them are set up in a similar fashion, right? Here, this top part up here, where it says internet setup, that is your wide area setup. That's your wide area setup. And this is set up here again using automatic configuration. It means that it will allow your internet service provider to automatically assign it an IP address. This bottom half, this is your LAN section. This is your local area network. This sets up the IP addresses that's going to go out to all of your clients, all of your user devices. So that's what we're talking about, the difference between local area networks, wide area networks, and how they apply to your home or small office system. Okay, does that make sense? Now, one thing I did want to kind of circle back on, because you're probably still sitting there going, wait a minute, did he just say that my internet service provider is not the internet? Why am I paying them money? Well, what they do, they get you to the internet. It's like this. Think of the internet as Interstate 20, okay? Or Interstate 40, or whatever the interstate near your house, Interstate 85, Interstate 95. Okay, that's the internet. That's just going back and forth, letting you get from point A to point B, right? Well, to get though, let's say if you were going to go to a amusement park, Six Flags, and Six Flags is off of exit 427 on Interstate 95. Think of Six Flags as the World Wide Web. That is the service you want to get to. Think of exit 495 as your internet service provider. And think of the internet as, Interstate 95 as the internet itself. Likewise, for you to get onto the internet, onto the interstate, too many enters here. You have to, I don't know of any other way of getting onto the interstate except what? Using an on-ramp. And think of that on-ramp, that exit, that on-ramp to get on as your internet service provider. They're the one that provides you the gateway to get to the internet. So that on-ramp, and how do you get off the interstate? If you're not, totally drunk or something, there's now in that case, there's multiple ways of getting off of interstate. You don't want to try those though. But a normal sane person is going to take an off ramp. You're going to exit. Again, internet service provider, that on and off ramp that gets you in and out. All right, so we covered quite a bit of topics today, didn't we? We talked about the OSI model, right? and how the protocols at different layers and how they work. And so if you got a sender who wants to get to a receiver and the protocols in between. And we actually we covered protocols. Then we use an analogy to show you how the network that we use today is very similar, not the same, very similar to the U.S. postal system. Because it's all about transportation, how we transport. And then we showed you the differences between local area networks and wide area networks.